Bismillah ar-Rahman ar-Rahim. Hello and welcome everybody. Today, inshallah, we are going to start the tutorial for chapter 9, which is talking about the center of gravity, center of mass, and center of other. Now, to begin, the center of gravity or center of mass or the center of anything represents, like, say, for example, if we have uh, like a body with a weight, okay, so the center of the gravity will be where the resultant, okay, occurs or passes. Okay, so it's the location where the resultant force acts. While the centroid is the point defining the geometric center of an object, okay, regarding the geometry. So the center of weight, we can say the center of weight is the same or at the same point with the centroid if the system we are dealing with is homogeneous, okay? So this density will be the same everywhere. So to calculate the center of gravity or the center of mass, we can say, okay, the centroid x bar in y, so y capital, z capital, okay. The first part of the chapter we are dealing with integrations. So we have differential elements. So here you can say, okay, it's the integration of x tilde dw over integration dw, and the x tilde y tilde z tilde are like the centers or the centroids for that specific differential element, okay. Here it will be y tilde dw over dw, and finally it will be z tilde dw over dw. And of course we can replace the weight dw, okay, by the length dl, the area dA, the mass, okay, dm, and finally the volume the volume, okay. So the same procedure of the integration. And the second part will be we are going to deal with composite bodies. So we will be replacing the integrations by summations, okay. Here we have the integration, okay. Uh, so now we can start locate the center of gravity y, and of course to not to forget, so that I can't forget, shall mention that the centroid, if the body is symmetric, the centroid will be what at the center, okay. So if an object has an axis of symmetry, so then the centroid, we can say, of this object lies on that axis, okay. Locate the center of gravity y bar of the homogeneous rod. So here we are dealing with what? Line and dl's, the length. So here it's they are requiring from us to find y bar. So we are going to use this equation. Y bar equals to the integration of y tilde dl over the integration of dl. Okay, so it's given y is equals to x squared, and dy over dx, because we are going to use it, will be just 2x. Okay, and dl will be dx squared plus dy squared square root. Okay, and if we take dx squared out, okay, from the square root, we can say it will be dx, and we will divide dx squared by dx squared, it will be 1, and dy squared over dx squared, we can say dy over dx and squared. Okay, now L is what I have divided this integration into two steps. So first L equals to the integration dl and the integration of y tilde dl. So here I will just integrate from 0 to 1, okay, to 1. Okay, here it is in terms of dx, so dx is from 0, okay, to 1, okay. So if I take dx, this small differential element, I will integrate it from 0 till 1 meters, okay. Uh, and of course the dl squared is like I have to this dx and this is dy, so dl will be like vice versa, okay? So I can get the result from the calculator, and we can note that all the equations should be consistent with one variable, so it's all in terms of x, as the differential element is in terms of dx, okay? Now y tilde dl, y tilde will be the same as y, okay? So y is x squared, the equation is given, so we can say okay, it's x squared, and dl we have already found it, okay, to be you can say okay, you can take this here and you can do the integration and you can get the result, okay? Or you can in one step just put the integration up and down, and in the calculator you can get the result straightforward in meters, of course. Now here the same equation, but we are dealing with dA, so centroid of an area, okay? Here we have two problems: locate the centroid x of the area and locate the centroid y bar of the area. And in both cases, it will depend of dA. So be careful how to define dA, because sometimes it will be easier whether you will take the differential element as vertical differential element or a horizontal differential element, okay? So here, if we take the differential element to be a vertical differential element, okay, so we have dx, okay? So dA will be what? dA will be y dx, will be y dx, okay? But say, for example, a student like wants to take the differential element to be a horizontal one. So here he will say, okay, dy, okay, and dA will be what? Will be like x dy, but x in our case here the differential element here, the length, it's not x, it is b minus x, because the total length is b, okay? But here in our case it is just y, because here it is y, okay, multiplied by dx. So in this case will be easier, okay, to define how to define the differential element, because here x tilde and y tilde here, okay, y tilde will be just y, okay, it's on the curve, but x tilde here is x tilde, okay, let me erase this. Here x tilde is in the middle, correct, the centroid of this small differential element here. So it is not x, the x is still the curve, okay, here it is x, okay, so it is x plus this small distance, which is what? B minus x over 2, okay? But in our case, since I have taken the differential element to be a vertical one, okay, so it's just dA equals to y dx, and y is given to be what? H over b squared multiplied by x squared, okay? So here the differential element is in terms of only x. So all the equation should be in terms of x, since we are dealing with dx, okay? So you cannot see which one will be easier. And here also x bar, x tilde will be what? X tilde will be just x, okay? Let's compare here. X tilde was x plus b minus x over 2, okay? Now we are ready for integration. So integrate x tilde dA over integration of dA, and from what? 0 till b. Here is our differential element. We are integrating it from 0 till b, okay, to get the centroid of this curve. So here, x tilde, we have said it is what? X, okay? And dA is what? Is y dx, and y is given to be h over b squared x squared, okay? Here, okay? So we can just integrate and do the math, okay? So here it is x and x squared, it's x cubed, And after integration, it will be to the power 4 divided by 4. And here we have h over b squared and h over b squared. We can cancel them out, okay? And finally, and here, of course, integration of x squared will be x cubed over 3. And finally, we'll get the result to be 3 over 4b. And here, everything is in terms of x because we have dx. So only one variable, okay? Now here, we are, also we have the it's required from us to find centroid y bar. So we will use the equation, okay, integration of y tilde dA over integration of the differential element dA. Okay, now we have already defined it as a vertical differential element. So dA will be the same. So y dx, correct? Here it is y dx. Okay, so the height is y and the length, the horizontal length is dx. Equals to what? As same as part one, h x squared dx over b2 because y is given as h x squared over b2. Now y tilde, we have said it's y over 2. Okay, y tilde is what? The centroid of this small differential element is what? Here it is y because it's on the curve xy, and here it is x tilde y tilde. So here will be what? Will be the total, which is y over 2. Okay, so y over 2, now we can substitute. Here it is y tilde, the equation here, y tilde, which is what? Y over 2. And y is what? H x squared over b squared given in the problem. So we can divide it only by 2. Okay? And here is dA. We have already defined it. Okay? H x squared b squared, check. Here, h x squared over b squared. Okay? dx. And here it will be just this part. Integration of this part, which is d. Okay. Now we can do the math. Here we have x to the power 4, and here we have what? X to the power 2, and here we have h squared over 2 multiplied by b to the power 4, and here we have h over b squared. Okay, so here you can do the math, and you will get what the result to be h over b squared. Okay, so here it is hb squared, and here we will do the integration x to the power 5 over 5, and here x cubed to the power what? X cubed over 3. And we can substitute, okay? Replace x by b and do the simplifications, okay? And here I took only here h over b4, b to the power 4, okay? So here I have 2, and it will be here, okay? So this is our result, y bar, 3h over 10. Here now, the second part, we will be dealing with the same equations here, okay? Just we will replace the integration by summation. So it will be maybe easier to the students. And of course, we have, instead of d, will be just w, okay? So say for example, x tilde or x bar equals to x tilde, the weight over the weight, okay, summation, okay, of course, the same applies to y and z. Or we can say, okay, we can replace w by either a, l, m, or v, volume, okay. So here we should define or like divide the composite shape into small parts, okay, that we can know its or their centroids. So here we have what? Areas, correct? So our equation will be x bar is equals to summation of x tilde a over summation of a, and y bar equals to summation of y tilde a over summation of a's, okay. So here we have defined, also we have the axis, y-axis and x-axis. So it's clear that anything in this part will be what? Negative, okay. And here we have a hole. Here the half circle or the semicircle is a whole, so it will be negative. The area is negative. We should subtract it. Okay, and we have defined the like triangular shape is A, B is the rectangular shape, C is the quarter of this circle. Okay, and D is what? The semicircle. Okay, and it will be negative. Okay, and finally we will take the summations. Now the area of each part, the triangle is what? Half multiplied by 3. Okay, multiplied by the height, which is 3. Here the radius is a 3. Okay, so here it is a 3 meters. Okay, x tilde of this triangle, x tilde, the centroid of this triangle is what? It is 3 meters plus what? Here it is what? 3 h over 3, which is 3 over 3 is 1. Okay, so it is minus 4 since it is in the negative x-axis here. Okay, y tilde is what? Again, we will say y or h over 3. Here the height is a 3, so 3 over 3 is 1 in the positive y-axis, so 1. So now it's x tilde multiplied by the area. Okay, we'll get minus 18, and y tilde multiplied by the area is 4.5. Okay, regarding the rectangle, the area is what? Here, let's check with this shape. Here, the area of the triangle is what? 3 multiplied by what? The height, which is 3. Okay, so 9. X tilde is what? Here, and it will be in the middle. So it is 1.5, but it will be negative sign. Okay, so 1.5. Y tilde will be what? It's also in the middle, in the positive y-axis, so it's 1.5. Now multiply x tilde A is minus 13.5, and y tilde A is 13.5. Regarding part C, the quarter circle, okay, here part C, okay, these shapes will be given in the exam. Okay, we are dealing now with the quarter. We can notice here that the centroid is what? From the y-axis, from the y-axis, from the y-axis, it is 4 multiplied by the radius over 3 pi. Also, from the x-axis, it will be what? 4r over 3 pi. Okay, so here we can note that x tilde and y tilde will be the same, 4r over 3 pi, 4r over 3 pi, and both are in the positive. Okay, so here, let's say here is the centroid. So here it's 4r over 3 pi, and here it's 4r 3 pi. Okay, and the area is what? Of course, pi r squared is the area of the whole circle divided by 4. Okay, so r squared, the radius is what? 3 meters, will be 9, so 9 pi over 4. Okay, now the semicircle, as we agreed that it will be a negative, the area, because we are going to subtract it. Here the area pi r squared over 2, so pi r squared over 2. The radius of this small semicircle is what? Is given to be 1 meters. Okay, so pi r squared, which is 1, r squared is 1, so pi over 2, negative sign. Okay, x tilde is what? Since it is at the axis, or it's symmetric about the y-axis, here the centroid is where? Is in the middle, correct? So we are not going to move either to the right or to the left. Okay, so here it is 0. Okay, hope this is clear. So it is at the axis of the it's the centroid is on the y-axis, so x tilde, we are not going to move in the x-axis direction, so it is 0 because it is symmetric about the y-axis. Now we should find the y tilde of this small semicircle, which is going to be somewhere here upwards, correct? It will have a value of what? 4r over 3 pi positive, and the r is 1. Okay, now x tilde a will be 0, and here we will get minus 0.67. Now we can do the summations. We will get x tilde a Okay, so here it's minus 22.5, and the summation of area is what? All the areas of the composite bodies or parts is 19. And here it is 26.33, summation of y tilde a, and the summation of areas is 19. The answer will be meters, meters. Now, we can always check if our answer is reasonable or not. X bar is minus 1.18. So it is somewhere here. So it is somewhere what here, okay? Minus 1.18, and Y bar is 1.39. So it's somewhere here, okay? So it's reasonable because it is like towards the heaviest part, okay? Now here we have the same idea, but we are dealing with length, okay? And I have divided my composite body into three parts, 1, 2, and 3. Now we can construct our table. Segment 1, the length of it is 200 millimeters, correct? X tilde, the centroid of this small segment is what? In the middle, correct? So we didn't move in the X direction, neither in the X direction nor in the Y direction. We just have moved here in the Y direction, which is 100. So 200 over 2. Okay, so X tilde, Y tilde is 0, and here it is 100. Now we can multiply X tilde by L, Y tilde by L, and Z tilde by L. Now regarding segment 2, here we should be careful. We have moved the centroid of it, of this segment number 2 is here, correct? So in the x-axis, how much we have moved? This total length is what? Is 600 cosine 30, correct? But we need just the distance till the centroid. So the centroid will be in the middle here. So we'll divide this by 2. So 600 cosine 30 over 2. Also, similarly, we will do the same here, okay? In the y-axis, and the centroid is in the middle to get the distance, okay? But it will be sine instead of cosine, okay? So 600 sine 30 over 2. And in the z-axis, it didn't move neither here nor in the upwards direction, okay? So it's only in the xy plane. So z is 0, okay? And we can do here the calculations. Number 3 is what? Here also, the distance in the x-axis direction is what? Here, okay, which is what? 600 cosine 30, okay, which is this length. So this is x tilde. Now regarding t tilde, y tilde will be what? 600 will be 600 sine 30, okay? And in the z direction will be what? 100 over 2, but in the negative negative z axis, so it will be minus 50. So here it's minus 50 because it's in the negative z axis. Here it is 600 cosine 30. Here it's 600 sine 30. Okay, we can do here also the calculations. Summation of L will be 900. Then we will do the summation of X tilde L, Y tilde L, and Z tilde L. Okay, and the units are in millimeters. And here in the summations, we should not neglect or forget the signs. Signs are important, okay? So we will just divide this number by this number, this number by this number to get y bar, and this number by this number to get z bar, okay? And we'll get the values in millimeters, and of course, always ask yourself, are they reasonable results? Okay, because they are going to always move towards the like heaviest zone. So here we have what? Here we have 231 millimeters, okay? So for example, somewhere here, x bar, y bar is 133. Okay, say for example, somewhere here also. Okay, and z bar is 16.7. So it is upwards. Okay, so it's upwards. Why? Because here 200, like we have length the length in the positive x z-axis is higher than the 100 millimeters. So if it's shifted, it will be shifted what? Upward. Okay. Now here also determine y bar. Now x bar, it will be located where? Here we cannot, it is symmetric about the y-axis. So x bar is going to be in the middle. Okay. We are not going, it's not going to be the centroid, neither to the right nor to the left, but it is going, of course, to be shifted upwards or downwards towards the heaviest zone. Okay, so here determines the central axis x bar dash x bar. Now here the reference is given. Okay, because here it's assigned y bar and here is the axis. Okay, so we will start from here. Here is our reference. Okay, of the beam cross section area. So here dA. Okay, now here's our equation. I always prefer to not use the table in just in like in one equation. I can find the results. Okay, here, okay, I divided like into two steps, but I usually do it in one example, in one equation. Why? Because little we will save time, little also errors because we are doing less calculations, and we can easily compare the areas up and down. So here, first of all, let's check here. I have divided this system or structure to three parts here: number one, number two, and number three. Okay. So regarding the first segment, number one, y tilde will be what? 15 over 2 because it will be in the middle, correct? So 7.5, and it's positive because here is our positive y-axis. This is determined, okay, in the problem. A1 will be just 150 multiplied by 15 plus the centroid of the second part here. Okay, it will be here. So 15 plus 150 over 2. Okay, so 15 plus 150 over 2 is 90. And the area is what? 15. Okay, multiplied by 150. The third part, we have a circle. So here, the centroid is in the middle, correct? So 15 plus 150 plus what? The radius. Okay, the radius, which is 50. Okay, and the area is pi r squared. Okay, we can say directly, okay, divided by the summation of areas. So here, summation of or A1 plus A2 plus A3. Okay, so A1 plus A2 plus A3. And in one step, we can get the result. Okay, but here I have divided it. So I got first, okay, summation of y tilde A in millimeters squared, summation of areas is millimeters squared. Okay, but if you use this equation directly, you can like do less calculations and hence the probability of error will be less, and you can easily compare the areas or take them from the up. Okay, here you will see what I mean. I didn't use any table. Okay, but anyway, here we are dealing with the center, or locate the center of mass. Okay, but we have volumes. Okay, so what will be different? Instead of A, we'll have V's. Okay, I have divided this system into parts, this composite body. So I have first, number one, this whole rectangle. Okay, number two is what? This small rectangle. Okay, and number three is this triangle. Okay, so better to write the equation and get the answer in one step. This is for me. So as it will be less calculations and less error probability, and you can compare like volumes and volumes or areas and areas. So first of all, for each like segment, we'll find what? X tilde, Y tilde, Z tilde for part one, for segment 2 and segment 3. Okay. So here for uh, segment number 1, the X direction is here, correct? So it will be, the centroid is in the middle. So we have moved how much? 150 over 2. Okay. okay, which is 75 millimeters. Now y tilde will be what? Y, this is the y direction. So here, this length is how much? Is 100 millimeters plus 250 plus 200. Okay, okay. So it is 100 plus 250 plus 200 over 2, which is 275 millimeters. Now, this z in the z direction, here is the height 150, so it will be just 150 over 2, which is 75 millimeters. Okay. Now, regarding part 2 or segment 2, here in the x direction, we have moved how much here? It is 150, and the centroid is here for the second segment. So we will say 150 plus this length divided by 2, okay, which is 150. So 150 plus 150 over 2 will give us 225 millimeters. Okay, now y tilde, here is the y direction. So we'll say, okay, this length, which is 100 millimeters, plus this length, which is 250 millimeters, plus 200 over 2, because it will be in the middle. Okay, so 100 plus 250 plus 100, which is 200 over 2. We'll get 450 millimeters. Now, z tilde is what? It's just, again, 150 over 2, okay, which is 75 millimeters. Now, the third segment, which is the triangular one, here, the x direction is how much? Remember this like triangle in a 2D, okay, plane. The centroid will be at a distance of from here till here will be the distance of L over 3, okay? And from here till here, it will be a distance of how much? H over 3. But if it's a 3D, okay, let's say here it has an extension, okay? So we will say, okay, this length, this total length or depth over 2, sorry, over, so let's say here is our depth, okay, which is D. So in the third plane, we will say, okay, the centroid location is D over 2, okay? Here you can see what I mean. Regarding this triangle, x tilde, okay, will be what? Will be here, it's 150 plus what? 150 over 3, because here it is what? H over 3, okay? Y tilde in this direction will be what? Here is the depth. It's a 3D problem, correct? So it will be just 100 over 2, okay? It will be in the middle, okay? So 50 millimeters. But the z direction, okay, in the z direction, the distance will be how much? Here, it will be h over 3, okay, which is 150 over 3, okay? So here 150 over 3. And now we are ready. We have calculated x tilde, y tilde, and z tilde for the 3 segments. We are just going to plug in. Now, the volume for segment 1 is what? This is our segment 1, correct? This rectangle. So we will say what? 100 plus 250 plus 200 is 555 multiplied by what? The height, 150, multiplied by the depth, which is 150. So 150 multiplied by 150 multiplied by 550, okay? And here is from the first part, x tilde 1, x tilde 2, x tilde 3, okay? So x tilde 1, x tilde 2, and x tilde 3. And the volume for the second segment will be, here's our second segment, okay? The volume is what? will be 200 millimeters multiplied by 150 millimeters. Okay, so here 200 multiplied by 150 multiplied by what? The third the distance or length is 150. Okay, so 150 multiplied by 150 multiplied by 200. And x2 is what? For the second segment is 225 millimeters. Okay, x tilde uh, for the third zone or the segment, sorry, is what? Is 200 millimeters. Okay, 200 millimeters. And here the volume of the triangle will be the area multiplied by the depth or the thickness. So here is the area, which is what? Half multiplied by 150 multiplied by 150. So here is the length 150. Here is the height. It's also 150. And the depth is what? T or thickness or the depth is 100 millimeters. So here is the area of the triangle, half multiplied by 150 multiplied by 150 multiplied by the thickness, okay, or the depth. Okay, and here, as I mentioned earlier, we can just take these numbers down. Okay, because down we are just summing the volumes. Okay, so hence less calculations and less errors. So it's 120 millimeters, and you can ask always yourself, is this a reasonable number? Okay, so here 120 will be somewhere here. Okay, so it's towards the heaviest zone. Now y bar, we can also just copy the volumes. Okay, the same volumes of the three segments, and y1 tilde y tilde to y tilde 3 from here. Okay, for 50 and 50 millimeters. Okay, and we will get the answer to be 305 millimeters. So in the y bar, in the y-axis direction, it will be 305. So here it's 100, it's 250, it's somewhere here. So it is towards the heaviest zone. Okay. No, sorry, here it's 200, it's somewhere here. Okay, anyway, now regarding the final part, Z bar, okay, the same volumes again for the three segments, we'll copy them, but Z1 and Z2 and C3 tildes for the centroids for the three segments. Okay, we have already calculated them here, 75 millimeters, 75 millimeters, and 50 millimeters. Okay, 75, 75, and 50 millimeters, and you get 73.4 millimeters. So it is somewhere, it's 150, it's somewhere above or below the middle, because the middle it will be 75 millimeters. Okay, so by this we conclude our tutorial. Okay, thank you for watching, hoping that you benefited from this tutorial. Thank you.